can write this process as and it is white noise. So what is the difference between the first process and this process? There are two lags. So your yt depends upon its past two values. Then it depends on your past one value. This is called an AR2 process, auto-regressive of order 2. Its stationarity conditions are different. And you will learn about those stationarity conditions for the AR2 process if you go to the third semester. Right? Sure? Okay, I hope most of you go. Right? Okay, so if you go to the third semester, you learn how to check for stationarity. You have to find a difference equation, you have to find its roots, etc., etc. But that's a very important thing that you learn in the third semester, not in this course. Right? But I'm going to put up some videos nevertheless later on, because this, I want people to also know how to actually do that. Right? Okay, so yt minus 1, yt minus 2, etc. But the basic property remains that for this also you can get an autocorrelation function, autocovariance function, but the autocorrelation, autocovariance functions keep on falling. You get an additional quantity here. Here, you can think of the correlation between yt and yt minus 1. Now yt is correlated with yt minus 1, yt is correlated with yt minus 2. In this equation you can clearly see that yt minus 2 changes, yt changes, yt minus 1 changes, yt changes. So yt is directly correlated to yt minus 1 and yt minus 2. You don't have yt minus 3 in this equation. So is yt directly correlated with yt minus 3? No. Yt is not directly correlated to yt minus 3. But does that mean that yt minus 3 has no impact on yt? It has an impact. Because yt minus 3 will affect yt minus 2. And yt minus 2 will affect yt minus 1. And yt. So yt minus 3 will indirectly affect y. So there is no direct correlation between yt and yt minus 3. There is a direct correlation only between yt and yt minus 1 and yt minus 2. Okay? But no direct correlation between yt minus 3. There is indirect correlation. That indirect correlation will keep on falling. So to distinguish between the two, we also think of what is called a partial correlation function. Partial autocorrelation function, the PSEF. What does the partial autocorrelation function say? It says that there is the partial autocorrelation, there is a partial autocorrelation between yt and yt, which is a direct correlation idea. The partial autocorrelation concept captures the idea of direct correlation. It says that there is direct correlation between yt and yt minus 1. There is direct correlation between yt and yt minus 2. There is no direct correlation between yt and yt minus 3, yt minus 4, etc., etc. There is an indirect correlation with yt minus 3, yt minus 4, and that indirect correlation keeps on falling off. So the point now is, if you have a stationary AR2 process, then you must think of two objects. One is the autocorrelation function, which measures indirect correlation as well, where yt will be correlated to yt minus 1, yt minus 2, yt minus 3, yt minus 4, yt minus 5, and that correlation will keep on declining for a stationary AR2 process. You can also think of direct correlations or partial correlations, where yt is correlated with yt minus 2, yt minus 1, yt minus 2, but not with yt minus 3, yt minus 4. So you have a stationary AR2 process. If you looked at only the partial autocorrelation function, you will only get non-zero quantities for lag 1 and lag 2, subsequently zeros. But the autocorrelation function, which measures indirect autocorrelation, will obviously be there for all lags, so that will be declining. So for a stationary AR2 process, for example, the partial autocorrelation function will exist only for 2 lags, then 0 subsequently, and the autocorrelation function will be existing but will be tapering off. Very, very important. Okay, to repeat, for an AR2 process, you will get direct correlations only up to lag 2. So lag 1, lag 2, others will be 0. The indirect correlations are captured by the autocorrelation function will all exist but keep on becoming smaller and smaller and smaller as you go further and further back in time. So if you have an AR4 process, for example, if you have an AR4 process, how will the autocorrelation and partial autocorrelations look like? How many partial autocorrelations will you have for an AR4 process? 4. And the subsequent ones will be 0. But obviously, Y92 will also affect YT today because indirectly the effect will be very small. So the partial autocorrelation function will only up to 4 lakhs, but the autocorrelation function will keep on becoming smaller and smaller and tapering off because it's a stationary process. Right? Okay. On this note,
say that is continuous process then?
It's a continuous function. The ACF and the PSF are all continuous functions. So do we stop at this point? We have learnt a lot today. Please remember all this. This is very important. Right? Sure. So thank you.